All right, so this is page 10. Hopefully you've tried this already. Just try page 10. The process is intro homework. See how you do, and then I'll go over it. So for problem 1, a gas undergoes some sort of process as shown. So this is the PV graph. And when you're looking at this, hopefully you notice that my pressure, right, throughout, as I'm changing, so the volume gets bigger, and as I'm changing the volume, the pressure stays constant. So if pressure is constant, then this must be an isobaric process, because the pressure is constant, right? And barometers, bar means pressure. By what factor does the gas's temperature change? So as you can see, we start, so initially we'll call this volume like V initial, and then it's incrementing by, like, this is 2V initial, and then this is 3V initial. So the volume got 3 times bigger. So remember PV, this is our ideal gas law equation. PV equals nRT. Pressure is constant, the number of moles is constant, and that gas constant for whatever gas this is, right? It's kind of like it's like specific heat capacity in the sense that it's like different for each gas, but they're not the same thing. P and R are constant, so you can see V is proportional to T. So if my volume got 3 times bigger, then my temperature must have gotten 3 times bigger as well. So is the work done positive or negative? What does that mean? So in order to, the area under the curve is the work done, right? But or not work done, it just represents the work, the work either done on the system or by the system. How do you know if it's by the system, or how do you know if it's on the system? Well, you got to kind of visualize if we had our little chamber here, and we had a piston here. If the volume got bigger, that means the gas must have done work on the piston, right? In order to raise its UG or whatever, it had to do work. So that means the work done on the piston is positive. The work done on the gas is negative. So I'll say negative because gas does work on piston. And then, did heat enter or leave the gas? Explain. Let me think this through. The heat must have entered the system, right? Because what's happening is if these molecules are causing this thing to raise up, that must mean heat. I guess you don't have to even get to that level. The temperature raised, so that must mean the heat. There must have been heat added to the system, which caused the temperature to raise, which causes the volume to get bigger. So I'll say enter because temperature increased. If I get any of these wrong, by the way, please let me know. I'm not an expert at thermodynamics or anything. This is just how I think through these kind of problems. So number 2, 0.02 moles of gas undergoes some sort of process shown. Now, as you can see, both pressure and volume is changing. So we have a decrease in pressure, which results in an increase in volume. So it can't be isobaric because the pressure is changing. It can't be isometric because the volume is changing. It must be isothermic. This makes sense because we know isothermic graphs, they will make that 1 over x, rational, whatever you want to call it, kind of thing. It's going to make that kind of graph. What is the final temperature in C? I'm not going to lie, I actually don't know how to do this question. I guess I should do 2B first. What is the final volume, V2, to kind of show you how to do these kind of math problems. We could see that the initial pressure is 3 kilopascals. And then you start at 400 centimeters cubed. The pressure drops by a factor of 1/3, right? So it starts at 3 and then it becomes 1 kilopascals. So if you think about PV equals nRT, The temperature is constant because this is an isothermic process. The gas constant is constant, and the number of moles is constant. This whole thing is constant. So what this means is if your pressure dropped by a factor of 1/3, then your volume, in order to keep, right, because if the left hand or the right hand side is constant, the left hand side must be the same as well. If your pressure drops by a factor of 1/3, your pressure must increase by a factor of 1/3. So you get 3 times the volume, or instead of 400, it would be 1200 centimeters cubed. So I know that this V2 is 1200. So then how do you do 2A? Well, my first gut instinct was that, okay, so what I know is I know the number of moles. I know P1, V1, so this is like 3 kilopascals. I know V1 is 400, and then I also know P2 is 1 kilopascals. And then I know V2 is 1200 centimeters, and not 4,000, my fault. 412,000, or 1,200. So I don't know R, and I don't know temperature. Well, my first kind of thought was, well, I know P1, V1, so I can say P1, V1 is equal to nRT, and then I would do P2, V2 equals nRT. And then I can use a system of equations to kind of solve for R and T. But the thing is, if you go about trying this, it's just an infinite solution of equations, right? Because this P1, V1 is equal to P2, V2, which just means the nRT is equal to nRT, which is just like, duh. How do you solve for R and T? It's really an infinite solution of equations, I think. Another way to go about it is using the work equation. Work equals negative nRT ln V2 over V1. I'm not sure how you would use this equation, though. So I honestly don't know A. What is the final temperature in C? Well, I don't even know what it means by final, right? Because the temperature is going to be constant. And if you think about it, for this kind of a process, it doesn't matter what your temperature is necessarily, because no matter what your temperature is, if your pressure drops by a factor of 1/3, or changed by a factor of 1/3, your volume will increase by 3, or by 3 times bigger, whatever. So the temperature doesn't really affect that sort of like 1/3 and then 3 times bigger kind of thing. So I don't know how to do this. If you know how to do this, please inform me, because I don't know. But 2C, we can do. What happens to change in U, change in Q, and W. So change in U, change in Q, and then W. So the easiest one to do is work, right? Because you know the volume the volume kind of decreased. So if you think about this right here, if the volume went down, that means the piston did work on the gas. So work is positive. Piston does work on gas. Now for change in Q and change in U. So what I believe for change in U is that it stays the same. Or I guess change in U would be 0, right? So there's no change in internal energy. My reasoning for this is internal energy is related to temperature. So if you think about like what internal energy is, I think what I've read is that internal energy is really like the sum of all the energies of each particle of the gas, and then temperature is the average of that. So you can imagine temperature, if it's the average kinetic energy and U is a total kinetic energy, they're related. So if temperature stay the same, your internal energy must have It must change, right? There you go. There's 0 change in U. Constant, I'll say like 0 constant temperature. And then you're changing Q. If you think about U equals Q plus W. If your work was positive, then your Q must be negative. Heat must have gotten taken away. And I think conceptually that kind of makes sense, right? If your piston's doing work, trying to add to the internal energy, Q, heat must be taken away in order to keep the temperature constant. So changing Q, say negative. I'll just say because, I don't know, work is positive. Okay, so now we could do 0.5 moles of gas undergoes something. It undergoes some sort of process. Sorry, I just blanked out. Some sort of process. And we can see the volume is constant. So if the volume's constant, it's an isometric process. Determine the temperature at 0.1 and 0.2. So what we'd have to do is so this is going to be another kind of like system of equations thing. We know P1 V1 is an equal nRT1, and then P2 V2 is an equal nRT2. So I know that the pressure increased by 3. Oh, do you just get another, I think this might be another just, not infinite solutions. Because it's going to be 3 times bigger, right? If your volume got 3 times bigger, or sorry, your pressure got 3 times bigger, your temperature got 3 times bigger. So 3T1 is going to equal T2. But, I wouldn't, how would you go about solving that? Because I think this would be another kind of like, because if you think about P2 is really just 3 times pressure 1. And then V is the same, is an equal nRT2. But then if P1 V1 is equal to this, you could substitute that back in. You get 3 nRT1 is equal to nRT2. And then those drop, and you just get 3T1. Go to T2. I don't know if this problem was in our packet. I don't think I did this one. Like, I don't think it was even included. So I guess we'll just do 3B. Explain what happens changing U, changing Q and W. So this one is pretty kind of straightforward. Work, first of all, is 0 because the piston won't move at all, so there's no work being done. It's a constant volume kind of situation. Piston doesn't move. Changing Q is going to be positive, right? You added heat because temperature increased. And then change in U must have increased because temperature got bigger, but also if you think about first law of thermodynamics, if you add heat, your internal energy will increase. So heat was added. So I'll think more about 3A and 2A and figure out how to do those. This problem would, if you had R, you could do it. I'm not sure. Without R, I don't think you can do it. So that's just my hunch. But yeah, thank you for watching.